we can study about image position and nature of the image by using two methods. The first method is using diagrams. Using diagrams means using ray diagrams. Ray diagrams are used both in mirrors and also in lenses. We use ray diagrams while dealing with mirrors and while dealing with the lenses, and by using the ray diagrams we can easily explain the image position and nature of the image. The second method is using formulae. We use two important formulas, and with the help of these two important formulas we can also explain the image position and nature of the image. Mirror formula. This is useful while dealing with mirrors. And another formula is lens formula. We use this while dealing with lenses. See here, by using the mirror formula we can explain the image position and nature of the image while dealing with the mirrors. Similarly, by using the lens formula we can explain the image position and nature of the image in case of lenses. Now let us study about mirror formula. Mirror formula is a relation between focal length, image distance and object distance. 1 by f is equal to 1 by v plus 1 by u. Mirror formula is applicable to all types of spherical mirrors at all positions of the object. Mirror formula can be applicable to plane mirrors also. Mirror formula is sign sensitive. Mirror formula has to follow the sign conventions. While using the mirror formula we have to follow sign convention. Sign convention for the parameters related to the mirror equation. Parameters means measurable quantities, measurable components. Now what are the measurable components related to the mirror equation? We have object distance, we have image distance. These are directly related to the mirror equation, and we also have object height and image height. These are the parameters. These are the measurable quantities. These are the measurable components. How should we measure them? How should we measure them? There are a set of rules agreed by the experts how we should measure them, and this is known as convention. Convention means a set of rules agreed by the expert for the measurement. Now this is sign convention means, so these are the set of rules to be followed while measuring the parameters, while dealing with the mirror equation. Now let us discuss about how to measure these quantities. What are the rules for measuring these quantities? Now see here, all the distances should be measured from the pole. So here, if you take this as concave mirror, this is principal axis. Now this is pole. Now the first rule is all the distances should be measured from the pole. So whatever distance you want to measure, they should start from the pole. If you want to measure a distance, suppose this is an incident ray, a light ray is incident on the concave mirror. Now when the ray is moving like this, now if you, for example, consider this is object O dash, this is height of object. Suppose this is object. Now this object distance you want to measure from O to P, this is object distance, or you can call it as U. If you want to measure U, object distance, you have to measure, always measure the distance from pole only. From pole you have to start. From pole you have to start. All the distance should be measured from the pole. If you want to find the object distance, you have to start from pole and move like this. Suppose we have image. Suppose this is image. Now if you want to find the image distance pi, you have to measure starting from the p only. That means either object distance or image distance you have to measure starting from the pole only. So this all the distances should be measured from the pole. Now coming to the second rule, you can say distance is measured in the direction of incident light are taken as positive. Now when a ray is falling on the concave mirror, now this is the direction of the incident light. Now if you want to measure the distance in the direction of the light, it should be taken as positive. If you measure the distance in this direction, you have to take it as positive. But in this case here, the distance is measured, the light ray is falling in this direction, but we are measuring the distance from here to here. That means we are moving against the direction of the opposite direction of the incident ray. So we have to take this distance as negative. Distance is measured in the opposite direction of the incident light or negative. See here, we are measuring the distance in the opposite direction of the incident ray. So we take it as negative. Coming to the height of the object and height of the image. So this is height of the object and this is height of the image. Height of the image. Now the height of the object and height of the image are measured upwards. If they are measured upwards the principal axis, I told you this is principal axis. If you measure the height of the object and height of the image upwards on the principal axis, we should take them as positive. That means here the object and image are standing on the principal axis, so we have to take height of the object and height of the image as positive. Now coming to the fifth rule, height of the object. Suppose we have height of the object like this, h0, height of the object, and we have this is, if the object and image, if the object and image are measured downwards downwards to the principal axis, then they should be taken as negative.